First of all, thank you very much for having me here with you guys. And it's really a pleasure to talk about what we're doing at Databloom AI. So basically, we're trying to build the federated analytics framework. And with analytics, we mean the entire pipeline, going from fetching the data from the distributed data sources, plus doing some data preparation, feature engineering, and so on, and the machine learning part. And this part, as we will see, we are trying to build also like the federated learning analytics. And for that, we are also leveraging a lot. We're starting to leverage Flower. And that's basically what this talk is about, how we come up with an added value to what Flower is doing today. So, yes. So let me start. We all know this figure. I think is quite famous by now. That was introduced by Google, right? Where basically they had the problem that they need to learn some models across the user's data. And the problem was that bringing the user's data to their servers, it was quite costly, because you are talking about even petabytes or exabytes of data. So they come up with the idea of, okay, let's push down the computation to where the data is. And that is what it was calling federated learning, right? And mainly one of the two features is the data privacy. Oops, let me see quickly in the chat if the messages are for me. Maybe something is going wrong. Okay, great, sorry. I just want, because maybe you were not hearing to me, that's why. So yes. And that is basically what Google come up, plus some model personalization, so that it's specialized or personalized to the users where you are running the Google app, for example. So that is what we know today as a federated learning. But this concept is in fact not new at all. It comes back from the 70s or 80s, where basically comes mainly from the data management community that was called Federated Databases. The only thing that changes here is the workload, the query you're running, while in the federated databases, basically SQL queries, analytical queries, where you have select, project, and some joins and eventually aggregates. Now with federated learning, you have more complex computations, which is basically learning a model that could be using SGD, or can be even running k-means or DBScan in a distributed manner and federated manner. But if you look at the architecture, it looks pretty similar to the common architectures that you will see, or the most popular architectures you will see for federated learning. And going here, for example, that's the Flower approach, and is a bit similar or quite similar to this federated approach. Again, there are differences. I'm not claiming here that there is nothing new. On the contrary, the federated learning concept is bringing new aspects that in the federated databases we were not considering there back in the 80s, for example. One of these concepts is data privacy. The main motivation in federated databases was more about you have data across multiple organizations or departments, and you want to run your SQL queries as if your data was on a single site, and you don't want to push all this complexity to the developer of splitting the query into multiple subqueries, sending it to the multiple sites, and then bringing the data or the results to a single place. Now in federated learning, besides Google introduced it mainly because you have a large amount of data. It's very costly to bring it to a centralized place. So now is getting more momentum, the privacy part, right? The data privacy. You have cases like think about hospitals. The previous presentation was talking about this, where federated learning, it will be like breaking this blocking pipeline in the analytics in the hospitals, because they cannot share their data. So Flower coming with this nice architecture and approach where it will allow developers to basically develop their applications in a federated fashion without worrying it on how the data is going to be moved, or the models will be moved to be aggregated on this server, let's say, and which strategy is going to be aggregated. You can easily select just one of that are provided by Flowr, like a Fed average and so on. But you can also come up with your new strategies, right? And then here on the client side, you can see basically that you can code that either on TensorFlow Federated, you can go to PyTorch, and you can basically come up with your federated pipeline in a very easy manner. That is what Flowr is giving us today, which is great. Now, what is the plus that we are doing? Plus, of course, in Flowr, you have this extra, as I mentioned, on how to do the aggregation. So, but if you go back to the pipeline of machine learning, or let's say federated learning in the entire pipeline, so basically we see that only this part, the model training, is where federated learning will take place, right? All the rest is parts that has to be done either offline or someone has to take care of this. And we're talking about ingesting the data to their system. We're talking about validating that data, doing some data pre-processing, and eventually do feature engineering, these kind of things, building the model, what you would like to do, and then do some model analysis, or even you can do some extra analytics or extra aggregates that is not related to model building. And then you eventually may either get the insights or deploy the model and so on and so forth. So you have a long pipeline that goes well beyond of what we are doing today in federated learning. So you already have some systems to orchestrate these multiple boxes, let's say, like Apache Beam. You have also Airflow and so on that will allow you to put all these boxes together like a scripting language, but in a more simpler and powerful way, right? So what is wrong with these systems, let's say? So two things. First, you have a still manual system pipelining. So the developer must do the pipeline and decide where the data has to go to the next step, like going from Apache Spark to, in this case, Flowr, for example, and so on and so forth. So the developer is responsible for all of this, meaning the entire performance on this pipelining relies upon the shoulders of this developer, right? So second possible problem with this is the system selection. And that is where Blossom at Databloom AI, it comes into the picture. If you think about, you want to develop any application, regardless on if it's machine learning or if it's a simple analytics, you need to decide what is the right platform to use. For example, in the case of Flowr, that you want to do some federated pipeline, federated learning, and you have on every side TensorFlow federated, PyTorch, Keras, and so on and so forth. What is going to be the right system to use to build, for example, a clustering, something that do clustering, or if you go to prediction, some regression tasks, and so on and so forth. So there, already the developers, before going into Flowr, you must know what is the system you would like to use on each of these sites, right? And that is the extra value that we will come with. And also in terms of performance, using for some particular workloads or tasks using TensorFlow Federated or compare it to PyTorch, one make more sense to use for a particular queries or task at hand than other tasks, right? So when you use one over the other, that's the main problem that developers are facing today as well. And that is where we come what we call the cross-platform data processing or cross-platform analytics. And what is the benefit of this? Let me show you this with an experiment that we did. So it's the cross-platform machine learning. And think about you are running some machine learning task using the stochastic gradient descent way, right? And for this, we did it with two different data sets sizes, that is 8 gigabytes and 15 gigabytes. This was a regression task. And the details, you can find it in the paper reference that you see there down on the slide. And basically the idea was simple. let's use Java and Spark on this particular case, but we are trying to benchmark, or we're already started to benchmark with real machine learning frameworks, like a TensorFlow, Keras, and PyTorch. But in this case, basically the idea will be the same, the message. So if you have Java and Spark and you want to run this machine learning task using any of these systems, if we're talking about 8 gigabytes, most likely you may say, okay, yes, 8 gigabytes, why to use Spark? Let's use just Java. But as soon as you go to higher data sets, larger data sets, such as 1 terabyte, then you will say, yes, it's way better to use Spark. In this case, we just went up to 15 gigabytes because it's clear that Java, for bigger data sets, it will be just a bottleneck. That is why we limited the data set size, but it can go to terabytes. There is no problem about that. So that is the performance you will see if you compare Java, that of course for a smaller data sets, running on Java is the best way. And for a bigger data set, running the Spark is the best way. But if you use both of them, Java and Spark, to execute that particular machine learning task, you will get basically order of magnitude better performance, right? And that's basically the point, that if I had to remove this Blossom part, this bar, and I would tell you what would be the best way to execute this, maybe you may have come with new frameworks, like run it on TensorFlow, run it on Keras, but in most of the cases, it would be pretty sure you will never say, what if you run it on this framework and that framework together at the same time, right? Because this is very hard to spot. And that is where we're trying to help in Blossom and getting this performance, and the accuracy is basically the same, quite similar to what you will get if you do it on a single system. We just run it until convergence. The question is, and the main challenge is, that is the landscape you have when picking what is the right systems. You have a huge landscape, and this is the big data landscape in 2020, in 21, already get more messy, and then basically we're talking about a zoo of systems and how we pick the right platform, which combination we should use among these animals is not that simple, and that is what we try to do again in Blossom, and bringing this new feature or intelligence for this particular system selection feature on top of Flower for federated learning, basically. And in other words, we want to tame these animals to work together, right? In a completely transparent way from users. And now we go, meaning for a particular task, how we can run that task in a fastest way or most economical way, if you are talking about monetary cost, so that the accuracy remains pretty much the same, but you improve these criteria, right? And that's basically what Blossom does. And the way it will look like the architecture, we are leveraging on top of Apache Guayan, that is basically this cross-platform core to do all the query processing over multiple platforms like Spark, Postgres, Flink, and so on and so forth. And for the federated learning part, what we are building now in Blossom is leveraging Flower, so that we do all this translation. Whenever we say you need to run it on TensorFlow or PyTorch at the same time, we relate in Flower to create this federated pipeline, basically. And we are sitting basically on top of Flower. And our job is to spot what is the right platform or system to use. And then basically the way it works, I will go just quickly because I'm running out of time. So giving a particular Apache plan, that is a query or a task that could be SGD or could be a simple SQL query, the first thing we do, this is going to be divided in multiple operators. Like a SGD will have also multiple operators to do the sampling, computing the gradient, averaging the gradient, and so on and so forth, right? So for every single operator, we find out what is the possible options where you can run that operator. We call that the plan inflation. Then after that plan inflation, for every single operator and option that you have, we find out what is that cost. And basically it's like what cost-based optimizers are doing. But in addition to that, to a single node DBMS, we will also spot or figure out what is the cost of running that on a multiple platforms, and that is meaning involving data movement cost. If you need to move data from TensorFlow Federated to PyTorch, it has some cost, and we need to take it into account so that we can pick the right configuration to improve performance or monitoring cost if you're running on the cloud. Once you have all this label, then we simply enumerate all the options with having some pruning techniques to prune the search space, because it's, of course, it's an NP-hard problem to find out what is the right execution plan. That is basically the output of Blossom. And this, if we think about in a federated way, we will have the options that Flower needs to use, and then we have automatic translation that will produce the Flower job, where in fact in Flower is also translating into TensorFlow or PyTorch and so on. And then Flower will do all the magic, execute it for us. We just give the hints to Flower where to run what. And basically now is not anymore the developer who has to take care of all these decisions, but Blossom comes with that decisions and Flower do the execution. That's the way we are doing it in the federated pipeline. But remember, there are multiple boxes, and that is how we integrate Flower, for example, with other boxes like Spark, Postgres, and so on. Blossom does all this coordination and move the relevant data to build the model into Flower, let's say. I mean, that Flower will run over that particular data. Now, just to conclude this talk, and before concluding, basically, I want to say that coming up with this cost-based optimizer is quite complicated because of the cost model. The cost model to have it well-tuned, because deciding if you will run it on TensorFlow or Keras depends on estimating what is going to be the cost of running SGD or a particular operator of SGD on TensorFlow, for example, or on Keras or PyTorch. And tuning that is really, really very complicated. And that is why we are replacing today this cost-based optimizer with a machine learning optimizer, machine learning base, that we remove entirely this cost model, and we don't estimate the cost for operators. What we do is generate a large training data set. We learn a model so that when we are enumerating the possibilities, the possible plans when running, we want to figure out what is the right combination. We just simply ask the machine learning model, or can be even using neural networks. It doesn't matter if it's using deep learning or machine learning. We just have a predictive model for performance, right? And then this will tell us what is the right combinations, and we continue enumerating and pruning the search space based on what the machine learning model is telling us. All right. So, and the details, you can find it in this paper below, that is there on the slide. So now let's see, when we compare, when we actually want to run our ML-based optimizer compared to the cost-based, when it really makes sense. So we run an experiment against using, in this case, K-means. And what we did is vary the dataset size. And we, again, use Java, Spark, and Flink. And we try to figure out if we restrain or to put the constraint to Blossom to use only one platform, if Blossom would pick the right platform to use. So forget about the combinations. Now we want to see if we can identify the best platform as a whole. That's the main point. And we see here the results. And here the triangles is the selection Blossom has done when using the cost-based optimizer. And the green one is when using the ML-based optimizer. And in this case, we see that here we didn't pick the right one, but of course, we are always on a sweet spot that gets harder to decide when exactly we need to switch to the right platform. So that is a complicated case. But then we see that we are picking basically the right platform, specifically the ML-based in all cases except for the small data set size, we pick always the right platform, which is not the case for the cost base. So in other words, the ML-based empower or AI empower optimizer, it gives better performance, and specifically, the user doesn't have to be involved on this. So now the user just send the query and sit down and get the results back in the fastest or most economical way. That is basically what Blossom is doing, and we are finalizing now our prototype. We should be done by fall this year, the entire integration with Flower, but the preliminary results are showing that are basically promising, and we are continuing that branch. And with that, I want to conclude this talk, and please visit us in our website or just drop an email in case you want to know more details about our product and how we are integrating Flower into Blossom at Databloom.